have the image of a tree on a 35mm color slide. The image on the slide is 1.5 millimeters high. It's to be projected onto a screen 3 meters from the slide and is to appear 493 millimeters high. What focal length of lens is needed? So a couple of things. If it's going to be projected onto a screen, what type of image does it need to be?
Real.
Real. So you should expect a positive S prime value. The slide itself is the object. So this is the height of the object, the 1 millimeters. The image we're getting on the screen is 493 millimeters high, so this is the height of the image. Now, to sketch this out a little bit for you, so our slide is here. There's light shining through it, goes through the lens, and then we get an image over here on a screen. Problem tells us that the distance between the slide and the screen is 3 meters. We know the distance from the object to the lens is S. The distance from the lens to the image is S prime. So this means that S plus S prime is 3 meters. Now to get a really big image, an image a lot bigger than the original object, our object distance, S, is going to be really close to what the focal length is. Remember, as we get closer and closer and closer to the focal length, the image gets bigger and bigger and bigger. Now magnification. We know the numerical value of the magnification is the height of the image over the height of the object. So the image is 493 millimeters tall. The object was 1.8 millimeters tall. So the numerical value of the magnification, I kept a few decimal places. So 273.89. Now our other equation for magnification, being negative S prime over S, we need to put the appropriate sign on this magnification. Remember, the numerical value of magnification is independent of the plus or minus sign. What does it mean to have a positive magnification?
Image is not reversed.
Right, it's not inverted, so it's upright. A negative magnification is an inverted image. Well, a converging lens that creates a real image, is that image upright or inverted? Will be inverted. So magnification, when we use this equation, we need to put negative 273.89. The negative signs will cancel, and we find that S prime is 273.89 times S. So S prime is a lot bigger than S is. Well, we can use this equation in conjunction with this equation. S plus S prime being 273.89S has to equal 3 meters. So 274.89. So S ends up being 0.0109 meters. So the distance from the slide to the lens is 1 centimeter basically. S prime, just plugging it back down there, S prime is then 2.989 meters. If we know S and S prime, we can use our nice relationship between S, S prime, and F. So 1 over the 0.0109 meters, 1 over the 2.989 meters. Solving for f, since this is my final answer, I rounded it to 2 significant figures. .011 meters or 1.1 centimeters, either's fine. Didn't specify a measurement unit.